All right, this next example, example 3, is probably the most tedious example that we're going to do in this section, and it has to do with this bisection method, because the process that we began in the previous example, where we proved that a equation has a solution on a particular interval, this does provide for us a way to hone in on or approximate what that solution actually is. And effectively, that algorithm is right up here, the bisection method. Essentially, what we're going to do is we first start off doing exactly what we did in the previous example. So let's get started with that. We'll sort of outline it really briefly here. So the first step would be to take our equation here that we want to prove the existence of a solution on, and we're going to go ahead and create a function of that. I'll go ahead and move the right hand side to the left hand side. So I will define a function. Let f of x be equal to sine of pi x plus x minus 1. And then there's also some language that I want to add here. Oh, actually, never mind. It's already added. Just wanting to make sure that we had this language of on 0 to 1/2. Okay, good. So that's added to the problem. It wasn't earlier. Okay, so we have our function definition. And now we have our first interval that we're going to work with. So let's go ahead and we're going to do a little visualization here. So I'm going to do these in steps. So I'm going to call this the first iteration. So for iteration number 1, let's just draw our little graph here. This is sort of just to help us visualize what's going on, what we're trying to assert here. So we have the interval 0 to 1/2. So we know where 0 is. I'll just mark and say that this is 1/2. And what we want to do, of course, is check to see what is f of 0 and what is f of, let's go ahead here. I'm just going to get my my calculator set up here. So what is f of 0 and what is f of 1/2? So for these numbers, I am not going to write down what the actual decimal approximation is. I'm simply going to state whether it's positive or negative. So I'm using a computer here to do this. If we go ahead and check this out, we are going to get negative for f of 0 and positive for 1/2. So then what I'm going to do here is I'm going to just, go ahead and illustrate this by putting just 2 dots. And again, this is not drawn to scale. I'm not saying what these actual values are. I'm just showing that at 0, we are below the horizontal axis, and at 1/2, we are above the horizontal axis. And then I'm going to go ahead and just say that, well, we know then there has to be some solution somewhere in between. Okay? So what we're going to do now is we are going to, at this point, since we know there is a solution somewhere in here, we are going to try to figure out which half of the interval, the left half, 0 to 1/4, or the right half, 1/4 to 1/2, what side of this interval does the solution lie? And the way we would do that is we would just find the midpoint. So the midpoint here, midpoint you always just average. So 0 plus 1/2 over 2 is 1/4. So that's our midpoint. So now that's going to be our new value here. And I'm going to go ahead and I'm going to just call this C1 for now, okay? Call this C1. So for this midpoint, what we're going to do is draw one more picture here. Or actually, we'll keep the same picture here. We're good with, we're good with this picture. But this is 1/4. And now what we're going to do is we're going to test the value of f at this midpoint. So f of this value, 1/4, is negative. And I guess I don't even have to call it C1. In my notes I did, but we don't need to here. So we found it's negative. So what I'm going to do here is, again, I'm going to just symbolically represent this by putting a little dot below. And now, if I take a red thing and just trace it, now, of course, I'm drawing a straight line because I'm only doing this to communicate one fact, and that fact is that the solution to this equation does not lie over here in the left half. Because it's negative, so the solution is here. Has to be on this side. Because we're going from negative to positive, so there has to be a zero in between by the intermediate value theorem. So now this first step of the process provides for us a new interval, 1/4 to 1/2. And then we rinse and repeat this process yet again. Okay, so let's do it one more time. So again, I'm going to go ahead and draw a graph, so we have something to visualize here. And now this time, I am going to just put 1/4 and 1/2. Again, this is not drawn to scale at all. We'll go ahead and we already know what the signs are, so we don't have to do this little step here that we did the very first time, because we know it's negative and positive. So we can go ahead in blue and just denote this as negative and positive. And now we need to find the midpoint. Well, the midpoint is 1/4 plus 1/2 over 2, which is 3/8. So 3/8. And if we go ahead and plug that midpoint, 3/8, into the function, we are going to find that it is positive now. So at 3/8, we're positive. And again, we'll just connect a straight line segments connecting the dots, and this shows that our next interval is this one. The solution has to be between 1/4 and 3/8. So now, for the sake of this video, I'm not going to show all the actually, we can, yeah, I'll show them. They're pretty quick now. So let's do the next process. The first time you do this, it can be lengthy, but with all the calculations. But if you have all the numbers already written down, it's actually kind of fast. So we'll do this one more time. And we're going to go ahead and we have our graph. It's going to be 1/4 and 3/8. Again, we know that it went from negative to positive, so negative to positive. We have to get our midpoint. Our midpoint is just 5/16. I'm not going to show the calculation for that. You guys can do that. 5/16. And if you plug that into the function, you get positive. So again, 5/16 is the midpoint. We found it to be positive yet again. So connecting these with straight line segments just to sort of really visually make it clear for us that our solution has to now be between 1/4 and 5/16. Okay. Now, we're honing in on it fairly nicely, fairly quickly here. We want to make sure in the problem, though, let's pay attention. Let's take a moment to go back and see that this says approximate the solution to within 1/100th. 1/100th. Okay. So remember in the previous example, we talked about how finding a solution to this equation is equivalent to finding when this equation f equals 0. When it equals 0. So for a moment here, just let's say here's where the function crosses the axis, okay? And let's say in our little interval here, okay? In our little interval here, if we go ahead and let's say we plug in our midpoint, for instance, like right here, it's our midpoint. When we plug this into our function, I'll call this C. If we plug that into our function, this tells us effectively how far above the horizontal axis our function is. So this tells us how far away from being 0 it currently is. So what we want to do here is actually go until we can get this expression, the value of the function at the midpoint. We want this to be less than 10 to the negative 2. So less than 1/100th, more or less. That would be a good starting point. So if you go ahead and you compute what 5/16 is, it's not quite there yet. So we actually, in actuality, will have 2 more iterations to this process. So our next interval here will be, we'll go through these very quickly, will be 1/4 to 5/16. I'll just say that our midpoint is 9/32. And if we go ahead and plug that into the function, so if we go ahead and do f of 9/32, we see that it is yet again positive. So here we have negative, positive, positive. We see that our function must cross the x-axis somewhere between 1/4 and 9/32. So rinse and repeat. So we have 1/4 and we have 9/32. Our midpoint this time is 17/64. And that is actually, it's again positive. So negative, positive, positive, crossing here. And if you take a look at what f of 17/64 is, it's positive, but it is also less than 0.01. So if we go ahead, we can say that the answer, the solution, is x approximately equal to 17/64. Also, if you go ahead and use a computer or a calculator, you can figure out what this is as a decimal. This is as a decimal. I'll just go to the, third, I'll round to the third decimal place. This is, actually, I'll round to the 100ths actually. So 0.27. Okay, that's what that is. And if we actually use a computer like I used Mathematica, we can actually solve the equation. And the actual, so let's say that this is the, let's go ahead and say the approximated solution is that. The actual solution is approximately, because again, this is a numerical solver also, but with a lot more precision than what we just did by hand. This is, let's go ahead and write this down really quickly. So it looks like we have, rounding again to the nearest 100th is 0.26. So we are within 1/100th. Nice.